Okay, Bakun got water falling down. Okay, the water is the power, and that power is P equal to VI. Okay, so okay, the I, the V in Bakun is 11 kV. Okay, so the I is very huge. Okay, I think I showed you in last class the Bakun. Okay, let me show you one more time. Okay, so this Bakun, you see this one is the incoming from Bakun. The outgoing, you can barely see it. Let me try to expand it. You can see it. Can you tell me if you can see or not? Wait, when I expand, you can see or not? Because my former computer, when I expand, people cannot see. Okay. Okay, because when I do full screen in PowerPoint, they cannot see. But this is my new computer. Okay. 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 So you look at this. So this is the incoming from Bakun, red, yellow, blue. Okay. And the outgoing, you can barely see it. Okay. You can barely see the wire. You can see a small dash here. That's a 275 kV. Okay. Why is that? Because this 11 kV, 11 kV is low voltage. The wire side, you just remember one thing. In electrical, you got four things. Okay. In electrical, you got four things. Okay. PVIR. The wire size only depends on the I. It doesn't depend on any of this. Okay. A lot of people don't know this. I know one Petronas manager, very high up. I met him. He said, no, should be power, big wire. Very senior Petronas manager. Okay. You see, that means a lot of people don't know this one. Okay. So you as electrical engineer, you must remember only I determine the wire size. Okay. Okay. Wire size only depend on I. Okay. Okay. So Bakun operates at 11 kV. It's 11 plus minus a bit, sometimes 15 kV, all the different power stations in Sarawak. Okay. But most of them operate around 11 kV. Why? Because if not, human cannot stand inside there. Okay. There'll be electrocution flying here and there. Human cannot survive inside there. Okay. And not only humans, even the equipment will start getting electrocuted here and there. Okay. So 11 kV is just nice. Okay. They've designed equipment to operate 11 kV. Okay. So that's why all the power stations operate at 11. And then they step it up to 275. You can see the wire there. The wire becomes so small. It's actually about this small. It's about 1.5 inch. Yeah. Okay, 1.5. 1.5. No, this one doesn't have. 1.5 is 2.5. Somewhere there lah. About there. Okay. Well, you can see that. It's about that lah. Okay, it's about that. That's a 2.5 wire, you know. 1.5 inch. Okay. Just about that 1.5 inch. Okay. So it's not big. 2.5 is the biggest power, you can say, biggest power wire in Sarawak. It's only this big. Okay. So it's not big. And some more, the center of the wire is actually steel. It's not a conductor. Okay. Why is that? Okay, let me explain to you. A bit of basic electrical. I explain to you. Okay, you see, you got two coils there. The magnet turns, right? The magnet in the center is an electromagnet. Okay, so when this coil and this coil is actually the same wire. You go clockwise there, and then you go anti-clockwise there. Okay, like that. Okay, so when the magnet passes this one, it pulls current to Sarawak. When it passes the bottom one, it takes current back from Sarawak. Okay, so the wire going into Sarawak is back and forth. Okay, so you have a wire like this. Okay, this is the power wire, right? The electron is just moving back and forth. Okay, this go back and forth, and next one go back and forth, and next one go back and forth. Okay, so it's not going continuous. So that's why a good explanation by one guy is, if I'm a Cisco power station, if AC, the current is going this way. DC is going like a pump. Okay, DC is going like a pump. AC is going back and forth. Okay, so you know the form 1, form 2, you learn about this one, FBI. Okay, you must put like a gun first. You put like a gun, and then it's FBI. Okay, if you don't put like a gun, you put like that, wrong already. FBI, wrong already. Okay, you must put like a gun. Okay, yeah, that's why you must remember the American Secret Service is using gun before, right? So then you remember it's a gun, then FBI. Okay. Okay, if you put like that, wrong, is it? FBI, wrong already. Must be a gun. Okay. So what is the FBI? F is the, in school, form 1, form 2, they teach you is the force. And B is a magnet north-south. And I is a current. Okay. So you have a wire like this. It's like this, and it's going this way. You got current this way. Okay. Current this way. Okay. So, okay, what is happening? You see in my book, where's my book? You can find my book in the library. Let me check. Where's my book? Hey. Oh. Okay, never mind. I don't have my book here. Oh yeah, I do have it. Hey. Oh. Okay. Okay, this is my book. Okay. Okay. So in my book, I don't put this as force like you learn in form 1, form 2. Okay, because if you put it as force, then you cannot explain everything. How transformer work. You know, transformer got two coils, right? How current can go from here to here. There's no movement. There's no F out of FBI. And there's no connection between the primary and secondary coil in the transformer. How can current from here can go here? Okay. So you cannot explain that if you look at this as force, because the transformer don't have any movement. Okay. But if you use F, the F is variable field density, then it can work. Okay. FBI, variable field density, then it can work. Okay. So Okay, so what? How is it variable field density? You look at this. Here, the electron. You see, electrons are magnets. Okay, electrons are magnets. Remember that they're tiny magnets. Okay, so say the electron is facing down north south. Okay, and then it moved this way. It, it moved this way. The current moved this way. Okay. Say you have a magnet. You have a magnet. You have a current this way, right? Inside a AC cable, the electron is moving back and forth. Okay, moving back and forth. Okay, so you look at the same FBI. What is happening inside there? It moves here at maximum speed here, and then decrease speed until reach here, zero speed, maximum speed, reach here, zero speed. So it's zero speed, maximum speed, zero speed. Okay. So when you have this one, when the electron is at this point, you assume it's just 10 field lines. Okay, the magnet has say 10 field lines. Okay, okay. The electron magnet has 10 field lines. Okay, so at t plus 1 you got 10, t plus 2 you got 10, t plus 3 you got 10, t plus 4 you got 10. So there's a lot of field lines here. Here where the zero speed is only 10. Here, because they're merging with each other because of super high speed, right? They're merging with each other. You got all the field lines here maximum. Okay. So what you got? You got variable field density already. You got variable field density. Okay. Same thing as this one. You see. You got, say this one also 10 field lines. When it's far away, that one see one only, one field line. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. What is the wire seeing? The wire is seeing a variable field density. Okay. The wire is seeing a variable field density. Okay. A variable field density. Okay. So, in this one is moving back and forth. You also got variable field density. You got 10, you got a lot, and 10. So what you're having, you have the variable field density already. Okay. And then you got magnet, because electrons are magnet, it's north south. Okay, then you got current this way. So which direction? You look at it. Okay, it's going this way, it's this way. But some magnet are this way, that way. Some magnet that way, that way. Some magnet that way. So what is happening? From the center, there's current generation going out of the center. From the center is going out to the circumference. Okay. So that is current generation that you don't want. As an electrical engineer, you don't want this one, but it happens. So what is happening? It pushes the whole Bakun electron also to the outside. Okay. So the flow of electron inside the AC cable is only on the outside. This thing is called skin effect. Okay. Okay. So the electron is only flowing on the outside. So what they do in the overhead lines, they put steel in the center. Okay, steel. So the rest is aluminum, but the inside is steel. Why? Because aluminum is very brittle. So if they use aluminum, your span must be quite short. You use steel in the center, you can put it further. See? Understand, huh? If it's too close, it's very expensive. The towers are very expensive, right? But when you steel, you can put it further, you can use less towers. I heard for 275 kV, 2 towers is already a few million. Okay, just 2 towers, 275. That's why they say you get a project from Cisco, 2 towers, Cisco market. Okay, okay. So, okay, so that also enables you to explain a transformer. You see, transformer is like this, two coils. There's no connection between the two coils. But transformer is AC. So the current is going in and then going out, going in, going out. We draw it as sine wave, but the meaning of sine wave is actually going back and forth. Okay. So current going in and going out, going in, going out. What's happening? This becomes north in a half, next half cycle becomes south. North, south, north, south, it flips. Okay. So what is happening when you have north, south flipping like that? You got variable field density. You got F already. Okay. You got F. And then you got B. Why? Because the solenoid is a coil, it's a magnet. Okay. So you got B. So you got I, this I generated in the secondary. Okay. So that's how transformer works because of the FBI. Okay. From the primary, you can go to secondary because you got FBI. But you don't take F as force, you take it as variable field density. Anytime there's a variable field density, you got a magnet, you got I. It's I. Okay. So that's why the overhead line, the center is steel. Okay. The outside is aluminum because it only use actually 1 cm of the outside for transmission. The rest of it is unused. Okay. Okay. So okay. So I show you the picture of that one again. You can look at it. You see the 11 kV incoming is humongous. I took this from far away. Actually, sorry, I didn't take it. My friend took it and sent it to me. Okay, he's from the top of the dam. So you can imagine lah, from the bottom it must be huge. Okay. So this from the top of the dam. So I can't imagine. I don't think you can put your hand around this. It's too big for you to put your hand around this. Okay. And that's the 3 wire regular blue. And you can see this one, you can barely see it. Okay. So why? Because 275, the current goes down. Okay. Okay. So basically what you're doing is you're putting the V very high and the I goes down. The V goes very high, the I goes down. Okay. When the I goes down, wire size becomes small. Okay. So the initial system was Edison. Edison made the initial electric system, and he was using DC. So he can only transmit about 1 kilometer away. Okay. From the university to my house, that's it. You can't go further than that. Out beyond that, you got to put another generator. Okay. So which is actually good for business. So Edison was a businessman and he can make a lot of money this way. Every 1 kilometer he can sell one generator. So it's good for business. But Tesla is not interested in business. He's more interested in the truth and getting things right. Okay. So now we can have Bakun supplying the whole Sarawak. Okay. So far away, just one station. Cannot sell many things. Just Bakun one time you build and then cannot sell anything. Edison system, you want a new housing estate, one generator. New housing estate, another generator. Okay, and then you need people to supply petrol. Okay, so it's very business friendly, Edison system. But Tesla system is not business friendly. One person make the money. Okay, but eventually that one person need to distribute the money lah. In the future is for sure lah. It's going to be a robotic world. That one person must somehow give his money away. Okay, I don't see any other way because when robots take over everything, how people want jobs lah. Okay, so that 1 or 2 people who is making all the money from Baku and all that need to give the money away somehow. I don't know how it's going to work lah. I mean, how you deserve more money, how you deserve less money when you don't work. Okay. But I can tell you that, see, I ride a motorbike. I eat very cheap food, okay, because I'm vegetarian. I eat rice and moringa leaf every day, very cheap. If you live like me, you won't need so much money. Okay, so I don't know what's the future going to be, but maybe a combination of definitely robot going to take over because robot can do things more efficient. And some of the work that I've seen, because in my factory also I've seen those work loading this on a polishing machine. I must admit, it's not for human lah. It's just too robotic, too repetitive. I don't think a human's supposed to do that kind of work. Okay, it's just too repetitive for a human because you look at the history of human have never been doing this kind of thing, repetitive work. Okay, they've always been farmers and things like that. So in my conclusion, even my PhD thesis, I wrote that no, humans are not supposed to do this kind of work. Okay, so robots are, and then robots can do it better because they will make mistakes like humans. Okay, so definitely robots will take over. So a lot of people are trying to figure out how to distribute the money because there are cases where you give money to people and then they mess it up. The most famous case is the Red Indian of America, because I studied in a state called South Dakota. Okay? South Dakota is a rectangular state, like most of the US states are rectangular, right? So there's a Missouri River, part of the Mississippi. The Missouri River cut the state in half. Okay, so I flew from this side, from Malaysia. I flew from this side because this is the middle of America. So I flew from this side. And I looked down, and the pilot announced, "Okay, now we are. It's about 3 hours. US is so huge. By plane, it takes 3 hours to reach here. Okay, so from California, it takes 3 hours to reach here. Okay, so US is really huge. Okay, so the pilot said, "Okay, we have reached South Dakota." Okay, this is great. I'm going to study here. I look down. Oh my God, I made a wrong decision. There's nothing there. Sarawak got more things than this one. There's nothing down there. It's just jungle. Oh my God. Then I passed the river. After the river, 100% utilized. Cannot see empty space. All farmland, 100%. And then my university town was here. Okay. My university was at the border. Okay, to the next day. So I land down there. So I asked people, "Hey, what happened to this side? Why like this? Oh, they want Red Indian. How come Red Indian like that?" So later I found out the Red Indian, they're given dollars. 1987, 2000 a month. Oh, I just give you what is the 2000 meaning. I, as a student, I mop the floor and wash because I went to US without money. Yeah, so I mop the floor, wash the dishes. I make 1 to 6 something like that lah per month. Okay, so I make about 1 to 6 per month by mopping the floor, washing the dishes, and surviving. I can pay for my rent, my phone bill. I need phone. I mean, there's no handphone. It's a landline those days. Okay, but I need, because it's a 6 months of snow. Sometimes you are trapped and then you cannot call. You'll be in trouble. So everyone need a phone. Okay, my phone bill, my rent, my food, my books. Those days I had to buy book, or not like nowadays. You guys, my 2 children also just finished electrical engineering. They never bought a book also. Those days I had to buy book $80 for one book. Okay, by working like this, I buy all those books. Okay, so I can survive totally on 1 to 6 per month. Red Indian are given 2000 a month. Half month they're broke. Okay, okay. Okay, half month they're broke. So after half month they go and steal from other people. Okay, so it's one of the highest crime place in US. This place, one of the highest crime places in the US, because after half month, oh sorry, this one is all the other side. Yeah, so after half month, they start stealing from uh, from people lah. Okay, but the other side is all whites, all white. I'm talking really white. My whole class only one black hair American. All the rest were blondes. Okay, uh, then everyone has a gun free. You go to the supermarket, you can buy baju, shirt, trouser, gun, bullet. Like you can buy your shirt and trouser, you can buy your gun and bullet. Okay, totally gun free. Okay, most people think, hey, gun free, dangerous, and no crime. You want to shoot someone, they also shoot you. How can you shoot someone? Okay, really, no crime at all. Nobody dare to do a crime because you go to a house and steal, they can shoot you. So nobody dare to steal from somebody's house. Okay, there's no crime at all. Okay, the last murder was 1972. Okay, there's no crime. You want to start a quarrel, also you must remember, you want to quarrel someone, that guy can shoot you. So you really want to quarrel or not? You quarrel means you might die. Okay, so nobody quarrels. Okay, so okay, so so this is what people are worried about. You give money to people, they will end up like the Indians. They don't know how to handle the money. A lot of money, but they don't know how to handle it because they've never been through a hard life. As long as they are 18, they get 2,000 a month. So why should they work? Why should they study? They don't study. They don't work. You see, my university, all the Indian can go to my university, which is the state government university. The state government university is here. All the Indian can go in anytime they want, free, 100% free. The whole university of about 8,000 students, there's 6 Red Indians. And what they're doing? Art. They're drawing pictures. Okay? And that's the courses they take. Because they don't need to work. They're given free money. Okay? So that's why people are worried about the future, don't know what to do. If we give totally free, they will end up with the Indians. Okay? So there's a big argument going on how to we have to give money one day because you see, like Bakun making all the money and all the small people can't make money. So the big people are making all the money. They have to give the money to the other people. If not, how can the other people don't know what to do with the big money? Okay, Amazon, Amazon leader, Elon Musk, all that. They also don't know what to do with the money. Okay, so they have to give it out, but how to give it out? That's a big problem. Okay. Okay, so there are discussion about it worldwide. Every top business leader in Silicon Valley know that 100%. They have to eventually give out the money, but don't know how to give it out. Okay. There are a lot saying that we will move away from the need for money more into spiritual life, and we don't need the money, so we'll be more spiritual, something like that. Okay, that's most people are thinking that way. Okay. 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 So. Okay. So that's why basic idea of accident is that if you have a good organization, everything will run smooth. Okay. And then your accidents also be down. Okay. It's simple. You see, my first accident, I gave you the example, someone cut a finger. It's a simple thing. Get the vendor to repair that thing. Okay. Why is it not done? Now, I didn't have authority at that time because it's not mine is just to run the ship. So the person in charge of that garbage bin that caused someone's finger to be cut is supposed to do that. If I as a runner of the shift, go and tell the person, the engineer in charge of the garbage bin, he'll get angry. Say, why you kacau my duty? Okay. So you see, that guy was not doing the job properly, so it affects all of us. Okay. One engineer not doing the job properly affects the whole production. Okay. It's just like people say, hey, COVID started here, and some people say started there, don't care where it started. But it started somewhere. I didn't do anything wrong. Why I have to be affected by COVID? Someone did something wrong, but the whole world is affected by COVID. Okay, but definitely someone did something wrong. Okay, but the whole world is affected by COVID. Okay, so it's similar to that. Okay, one engineer did something wrong, and you cannot disturb him because he got his own ego. And you cannot tell him what to do. That's his job. We tell him someone got hurt, but he still don't want to repair the dustbin and design. We cannot do anything about it. Maybe his boss don't want to approve the budget, whatever. Okay. So because of this kind of issues, organizations are not run properly. You get this accident, which caused up. You can see the price I gave you from the first calculation. How much is it? That's people say don't want to approve the budget, but the price that we pay for that small dustbin accident, I can buy all brand new dustbin, much better quality. Okay, so that's why I'm teaching you this one, which is all safety engineers, safety lecturers will teach you this thing, that the price of accidents are terribly high. Okay, so maybe the engineer don't want to repair the dustbin because money issue, but if he can prove and show to his boss that one accident can buy all the top quality dustbin for the whole factory, just one accident's money. Okay, I can give you one example. I was in charge of one row of machine one time. Okay, one whole row of machine. That means every product need to come through my machine. Okay, so we have a cylinder. Okay. Okay, this is a cylinder. We call it cylinder, pneumatic cylinder. Pneumatic means you put air inside there. So you put air inside here, boom. Put air inside here, boom. Okay. So at the center of this piston, is a magnetic strip, a strip of magnet. Okay. So that magnet, we can put a sensor outside. So we can put a sensor outside, and then when the sensor is triggered, is a sensor to detect magnet. It's a simple magnet. It's called reed switch. Okay, it's just one flexible metal here, and this one is not movable. Okay, so when you put a magnet here, this will go down and contact. That's a simple switch. But it's well made lah. Okay, something is so simple like that, but for a toy you can do that, right? But when you're high tech, it must be made very, very carefully. Okay, so the sensor that we were using were two brands, Dakota, and SMC. Two Japanese brands, very, very well made, but they are plastic sensors. That means it's covered by the plastic. Okay. So what happened is the technician tied this one. They tie the sensor with a cable tie. Okay. The cable tie. Okay. So when this one go up, because it's a big one, this is about this big. Okay. This round. Okay. So bam, it make a the force, right? Boom. And when it go down, bam, 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 the cable tie will go down. So the sensor will go down. So what happens when the sensor go down? This one not yet reach the top, the sensor say already reached the top. So the sensor getting signal from, the PLC is getting signal from the sensor, and according to the sensor, it will do the next movement. The PLC will say, Suda, already reached, so I start the next movement. But this one actually not yet reached, but sensor say already reached because the sensor dropped down. Okay, so what happened? Crash. The machine crash. Okay, so it's a crash. Okay, so this was my machine. So very funny. There were 6 rows of machine. Uh, one row, got 2 machines. So I walk from one end to another end. Guarantee at least one will be crashing when I first went into this machine. Okay, so I start making improvement projects. One thing is, I found a German sensor. Okay, a German sensor called let me try to find. I got 2. Okay. Very funny. Uh, okay, TURCK. Okay, so the sensor that was used before I came, and when I first started, was this brand, Kuroda, and I said both made in Japan. Okay, and then I found online. Those days online very sluggish lah. Okay, but I managed to find. It's probably sluggish, but the truth, in terms of truth, those days now they add the fake news also. Okay. Anyway, so a German company called TURD. Yeah, it's not truck. It's almost like truck. Truck is TRUCK, isn't it? TURCK. It's a German company. 360 ringgit. Why I want to buy that one? Because these are plastic sensors. So if they use plastic sensor here, one way to make it not move is use a horse clip. Okay, horse clip, the one for the horse, the clip. Okay, but horse clip, I don't know. Some of you might not know what horse clip. Let me show you. Okay. Okay, this is horse clip. Okay, this horse clip. Okay, you put this, you tighten tight enough, guarantee it won't move anymore. It's quite sure. Okay. Okay. So for sure it won't move anymore. You put a sensor inside there. But problem is, the technician might tighten too tight. Tighten too tight, plastic will break. Plastic break, the sensor gone. Okay. So I found this sensor, which is metal. The only metal one was from this company. I just want a metal one. I don't care from where, as long as metal. Yeah. So I found this metal one, and it's 360. So to change the whole thing, I needed 16,000. Okay. So I need 16,000. The company also not doing that well at that time. So I needed 16. How to get money is 16,000. Okay. So what I did is I go and make a presentation. All the big boss attended because we tend to have meeting all the time. So one of them, I request I want to give a presentation about my idea. Okay. You give me 16,000. I know the company not doing well, but you give me 16,000. I can horse clip it. I can horse clip my sensor. Definitely, it won't move anymore. If it doesn't move anymore, there won't be any more crash. Okay. So even though the company was in trouble, they gave me 60,000 because of my long presentation. I give a long presentation, not ala. When you want money, you need to give long presentation. I gave a long presentation, and then they finally agreed, even though the company not doing well at the time. Okay, and I don't know who made the final call, but someone must know some safety numbers to know that a crash is not just a crash. A crash means a lot of money. I think one of them, the person in charge, knew these numbers. Okay, what I'm telling you now, which is not a very common knowledge that people know. Okay, so if you know that safety and any crash, even though it doesn't hurt people, it costs a lot of money. This one crash, like I told you, costs tons of money to the product. Okay, and with that money, you can easily buy the sensors. Okay, even though company is not doing well, they gave me a sensor. So I host clip all my sensors because metal sensor, right? I didn't realize when you go to such high price, the quality is different. It's not the same quality anymore. I bought two extra. This sensor I bought two extra. When I left about 10 years later, I worked in the company for 14 years. So I left about maybe 10 years later. I know, maybe less than that, maybe 9 or even 8 years later. The two sensors, the space sensor still on my table. This one, every 2 weeks, every week. See? Every week, 20 sensors I have to buy, 20 sensors fail every week. This one after make it 10 easy to say. After 10 years, no failure. I'm sure now is 20 years already, and I'm sure none fail. So that's why if you get from a good company like Turk, and there are certain top brands, not Alarm brand, I mean I'm talking about top brands. You get the higher end one, they last forever. You see, they're afraid to sell you this kind of thing because once you buy, you don't need to buy again. Okay, so there are certain brands like that. So you must search the market. Which are the brands? They are totally different type of quality out there in the market. Okay, some of them you buy and then next day it's gone. Some you buy until it can outlive you. Okay, I give you an example of my shoe. I went to US, no money, but I bought a shoe second-hand store, $2 second-hand. I still have it now. 1987 now. Okay, I think your parents also not married now. Okay, I'm pretty sure your parents not married. Okay, I bought it for $2. Okay, and I still have it now. Okay, and that is already used by some American. Okay, and I still have it now in my home in Kuching. Okay, so that's what brand is it? Hush Puppies. But I'm sure the Hush Puppies, because when I came back, I realized that it's such a good. I only buy Hush Puppies after that, but it's not the same quality lah. But it lasts long, good enough. Hush Puppies are good even if you buy in Malaysia, but definitely not the quality of those days lah. Yeah, now they put defects in there already. Okay. Okay. So you see, I told you that the dustbin engineer in charge of the dustbin could have made the correction. Okay, but he probably didn't have money. But if you can write a long report like this and give presentation, especially talk about the loss, like I give you the calculation of the loss of that dustbin accident, the finger accident, how much the money is, people can easily understand. Okay, whether go and get a new dustbin or repair the dustbin, no matter what it takes. Okay, because the money is so much. You can buy a new dustbin, perfect condition one. Okay, so that's why a lot of people don't understand the accidents cost so much money. That's why the accidents keep happening. Okay. Another case is, I think I did tell you one time, but I just highlight one more time. You see, uh, I was in charge of safety because when I was at school, 1 year I was in safety. Okay. Second year I was control room. But so when I joined Western Digital, they put me in charge of safety. I mean, one of the committee member of safety. Okay. So the leader of the group, you want to buy a safety shoe. Okay. So the safety shoe he want to buy is 80 ringgit. Red Wing, which is a standard shoe, I think some of you might have relative in oil and gas. They always use one kind of leather shoes, right? That's called Red Wing. It's a brand normally lah. If black color is a different brand, right? The leather color, brown color, is normally this brand, Red Wing. All oil and gas is almost standard. They use Red Wing. Okay, it's 350 at the time. Now it's much more lah. Okay, so I keep saying no, just buy Red Wing now. Why not buy this crazy shoe? Because I had experience when I was in Cisco. They buy a very cheap shoe. I tell you, I cannot use it at all. Somehow, it's just too uncomfortable. I'll go because I was in safety. I have to go to all the power stations. I in my car or maybe Cisco Hilux. Okay, I'll put it on, walk in power station. By the time I walk out of power station, I'm exhausted already. Okay, because uncomfortable. Okay, so that's why I know that one. That's why I insist you buy a Red Wing because I have a Red Wing. Not that I bought. My brother gave me. My brother in Shell gave me. Okay, he gave me 2 sets because they get one every 6 months. So he gave me 2 pair. I tell you, my Red Wing that my brother gave me in 1993 till now is still good. Okay, till now, 1993 until now still good. Okay, okay. So, and it's so comfortable. You're not tired at all. Okay, so there are two things. See, you get more productivity when you buy this one. That's very important. You're running a business. Your worker very happy. They make you more product and more careful product. Sometimes not fast. Don't worry about fast. As long as careful. Okay, don't make mistakes. Of course, they are very happy. Their feet very comfortable. They won't make as many mistakes as when their feet are very uncomfortable. Okay, I feel pity lah because I think that the Cisco shoes were superior to the one that this 80 ringgit shoe that guy bought lah. The guy in charge of the city. Okay, we as engineers, yeah, I think unfair lah. The engineers were given a better shoe than the workers. Okay, I'm sorry to say this, but I think I know what is his plan. He let the workers suffer. He knows that if the engineers use the same shoe, they will complain and ask him to change. So he purposely give it only to the workers, and then the engineers cannot complain to him. The engineers get, I mean, not Red Wing, but a bit better. Okay. So this kind of things happen in factories. Okay. So you see, if you look at productivity, you look at accidents, these things are just cheap price. You look at the numbers I gave you. Yeah. So the number I gave you last week was a bit wrong. Let me show you because I told you when the guy on the ladder died, right? When he fell down. Okay. When he fell down and died, Dodge came. Okay, so he shut down operation for 2 weeks. Okay, shut down operation for 2 weeks. So what's the meaning of 2 weeks? We have 6 BU, that means 6 rows of machine. 6 BU, 1 BU, 4 machines. Okay, last week the calculation I did something wrong. So let's do the calculation. 2 weeks. So 2 weeks times 24 hours. 24 hours per day. No, let me do it a week. 2 weeks times 7 days per week times 24 hours per day. Okay. 2 weeks times 7 days per week times 24 hours per day. And that's the total time. Okay. So divide by 10 minutes. Okay, divide by 10 over 60 hours. 10 over 60 hours. Yeah, 10 minutes, 10 over 60 hours. Okay. That's just one machine. Okay. That's one machine. That's one machine. But there are 6 BUs. That's 6 BUs times 4 machine per BU. Yeah, correct. Okay, so and then times 168 this per cycle. 168 this per cycle. Let me confirm again. Okay, 2 weeks, 7 days per week, 24 hours per day, times that's one machine. And how many machines there? You got 6 BUs, and each BU got 4 machines. And each of this cycle is 168 days. Each cycle 1 day. Okay, right. This is more. Oh yeah, times 2. Now I got the right number. Okay. 65 million. I knew it was something like that. So last week I did wrong. That's why I was a bit confused when I was on the board. I knew something was wrong. It should be around this number. 2 weeks is about 65 million. Okay. Simple, you read. 2 weeks down, 7 days per week, 24 hours per day times 1. That's one. Uh, that's one machine. That's one machine. And each machine had how many machines are there? There are 6 BUs, and each BUs had 4 machines per BU. That's 168 days times $2. That is this many 16,000 US dollar times 4. It is 65 million ringgit. That guy died. Cost 65 million ringgit. Okay. So you see, addition to that, what we do, we pay 50,000 to the family. We pay the family 50,000 because just kebajikan. Because we don't have to pay, we just pay 50,000 family. You look at the numbers. One guy died. Okay, so if you look at this, you look at this kind of numbers. You do whatever you take. Use the top ladder in the world. 100% best ladder in the world can offer you. You buy it. Okay, the most safe ladder, 10,000 ladder, never mind, just buy it. It's better than letting this happen. You understand? That's the whole idea of this iceberg principle. For us to, as a lecturer, to show you the price of accidents. Okay, I bought a ladder because I used to have the simple, in Cebu market and the whole Sarawak, mostly is the aluminum ladder, which is quite thin. Okay? I dropped down once in Kuching, planting some, some fruits now. I climbed up the ladder at the very top. I fell all the way. The ladder crushed feet below me. And then my children helped me. And then after that, I can barely walk. So I walked with my 2 boys. We went to a supermarket. Straight away buy 800 ringgit. That was those days, a long, long back. 800 ringgit from Patsun. Cebu also got Patsun, right? Patsun is a high end, I think, made in, I don't know, somewhere Germany or somewhere. Very tough leather. Okay. Because I don't want to fall again. And my children also insist, no, that with no money also, now I just buy the one. Don't want you to fall again. Okay. So I bought 800 ringgit. Later I bought another one, which is also another 800 ringgit. But you see, once I buy that leather, I never go back to aluminum leather again. So strong. Okay. You must know all these things, when you go to be an engineer. There are ladders that you spend a bit more money. It's so tough that it's very hard for you to fall. Okay. The aluminum ladder is easy for you to fall. This one is very hard to fall. Okay. It's so tough that it's very hard to fall. Unless you trip, something like that. You trip walking up the ladder or whatever. The ladder itself won't fall. Yeah. But it's so incredibly tough. Okay. So uh, uh, if we had bought, we have think of all this. You see, now I'm teaching you the whole engineers group of my factory didn't know this calculation because I was the only one who went through safety course. I was in Cisco safety 1 year, so they sent me for almost 1 year full of course, safety course. Okay, I think those days engineer didn't even take a safety course. Okay, so if you look at this number, buy the best ladder, 10,000 ladder, also never mind. It's still not even a dust compared to this kind of numbers. How many 10,000 leather can you buy with that kind of money? 65,000 divided by 10,000. Ha! Cannot be. Let me see. 6,500 10,000 letters. Okay. Okay. enough to buy 6,000 ladders. Okay, that cost 10,000 each. I mean, my ladder is very strong. I bought for only 1,000. 10,000, I don't know what kind of ladder. Okay, I bought a 10,000 ladder. But maybe this one is a bit taller. Okay, like 2,000 because mine 1,000, one story high. This one double story, so 2,000 10,000. Okay. So you look at the numbers, you can buy with this accident that happened in the factory, 10,000 ladder, you can buy 6,000 of them. Okay. So that's why accidents are terribly expensive. Okay. I mean, I keep giving you an example of the Cebu flyover in the airport there. If someone just, a tractor, accidentally move a bit slightly wrong, he go and make a structure fall down. If the flyover was about 100 million, one small structure like that, you can imagine probably at least one or 2 or 3 million. 3 million gone off just because the tractor driver drive wrongly a bit. Okay. Most of the guards in UTS, the older ones at least, I talk to the older ones because I used to play basketball in the university. So when I talk to them, a lot of them were tractor drivers during the timber boom of Sarawak. The old days there were timber in Sarawak, and now there's no more timber. Okay, so don't think you can get job in timber industry anymore. There's no more timber. Okay, that's why we need to move to hydro. Okay, our future is hydro. We cannot depend on timber or oil palm. Also, we cannot depend on it. Why? Because oil palm is a swamp crop. You grow it on the hill, it takes in too much nutrient, and normally one time and second time they say it's not worth it because the fertilizer that you put in is more than the output. So they don't do second time. In a lot of cases in Semenjung, the second time they stop doing it already. Okay, so the future is not oil palm. Our future of Sarawak is hydro. We cannot depend on solar. Solar just doesn't work. All the statistics, most of the cases, it just doesn't work at all. Okay. Okay. So we have to do hydro in Sarawak. Okay. Yeah. Okay. Okay. So that's the whole idea of the iceberg result, which is your exam next week. Okay. So you can just give calculation enough. Okay. At least I want to train you to at least learn to calculate. Okay, the real numbers. So just give this detailed calculation. I'll send you this later. Okay, so just give the calculation or the one with the finger cut one in the dustbin. Okay, and then in the finger cut one, if you choose the finger cut one, you can choose either this one or finger cut one. Okay, if you choose the finger cut one, you also explain if you are engineer in charge of all those dustbins. Your boss might say they don't have money, no budget to buy new dustbin. But if you show him the number, he'll buy it straight away. Okay. Maybe he don't want to buy because his boss might hammer him why he buy. Okay. But if you show the number, big boss also, a giant CEO also, oh yeah, definitely buy. Okay. Okay. So and the advantage now, what the Malaysian government have done is the safety officer must report to the very big boss, the top of the company. It's a law now. I mean, law not now. It's been a law some time back. Okay, the safety officer must report directly to the very big boss because government have already studied this for a long time and they know that accidents cost terribly a lot of money. Okay, so when I was in Cisco, the Malaysian number was like 8 billion. Okay, billion is a lot of money those days, In those days before Twin Tower, Malaysia just struggling to find money here and there, and we are losing 8 billion. I don't know what the number now is. It should be crazy amount of number. Okay, so if accidents cost that much, why are we letting them happen? Okay, That's why you see the work culture in America, because they have already learned this kind of thing, is so different. Mechanic is not like mechanic here. Totally clean. A bit of oil on the floor, they clean before they start work. Okay. I'm also more and more this way. See, I do a lot of work here and there, even in the Cebu house. I drill, okay, sweep the floor. You know, people say, no, sweep the floor is later, a different job. It's not, nanti, you know, some of the house I do, they say, ya nanti itu orang punya rumah boleh buat lah. No, you must do, because you already drill a hole, it's very dusty down there, and you still keep doing work. You might, you know, it's dusty, you might move dirt all over the house, one thing. And then it's not convenient, it's not safe for you to do dusty floor. Okay. You clean up, that one clean up first, then you start your next part of the job. Okay. So I'm very strict now. I drill a hole straight away, I clean properly, take a broom, clean properly, then only I start my next job. Okay. My next job could be a lot of job after that, but I clean properly. Okay. It seems like cleaning is not a technician's job, but it is. In CESCO exam, you don't clean, you lose quite a lot of points. Okay, 7 marks, 7%, sorry. If you don't clean your floor, by the time they do the final checking of your practical exam, 7% gone. 7% a lot of money, a lot of marks on. Okay, sometimes you can fail with 7 marks. Okay. Okay, so that's how the Westerners and Japanese they operate that way. They are very strict about doing their job right. It's all through experience. You see, I learned all this. Of course, I observe the Westerners and the Japanese. But my own conclusion also is like that. You need to be disciplined. You drill a hole, you sweep. You make some mess on the floor, you clean that mess before you start the next portion of the job. Sometimes you've got big pieces or sometimes even nails on the floor. Clean properly, then you start the rest. Don't say, never, I got safety shoe. Safety shoe also sometimes can poke through. Okay. And what if someone else who's not wearing good safety shoe poke through? Okay. Or you are in someone's house doing the job, and then some people not wearing safety shoe. Okay. And some house you cannot even wear safety shoe. And no, my house, how can you wear shoe? Okay. A lot of culture in Malaysia like that. Okay. Okay. I was doing one job in a temple, Hindu temple. The guy, what are you doing? Safety shoe? Cannot. Cannot wear safety shoe? Oh boy. Okay. So some due to culture they cannot wear safety shoe. Okay. Okay. So that's the whole reason why the Asper principle, and that's your next week progress test. Okay, you can either give this one, and this one you can give example. You see, of course, the root cause was the leather shoe was covered. Okay, I told you last class, the safety engineer decided the bottom of leather which has the rubber. Okay, the bottom of the leather has a rubber. It was covered with a shoe cover. Okay, this was covered with a shoe cover. That's the root cause. But if you, that's one thing lah. At least hope one of you become a safety engineer. You don't make that mistake. Okay, this rubber has a purpose. The purpose of this rubber is for friction. Okay, so you don't cover it with something. Okay, I was in Petronas last Wednesday, and that's one subject also. I think I got time to teach you that one now. You see, protection system of main switchboard. The main switchboard is the incoming of electrical for your building, like UTS. The main switchboard is in the red building where all the technicians are. Technicians of UTS are the red building at the end there. Okay. At the furthest end of that is the main switchboard. Main switchboard. Okay, MSB. Okay, main switchboard. So dB is your house one. Okay, your house one is dB. Let me try to find dB. Okay, this is a dB. Okay. Okay, this one is missing one component. There should be one more. I think I took it out to repair another house. Okay, there should be one more here. It's called RCD. So this is RCD, MCB, MCCB, MCBs. Okay, so that is okay. That is okay. RCD, MCCB, and MCB. Okay, so you must know each of them. It all come on your exam. Okay, so but this is the dB. Okay, in case you didn't take Wyman, you see the incoming is okay here. See, this is the incoming. These two wires here are the out of the RCD. The RCD I took it out already to repair one house in Cebu. Okay, so this RCD. So incoming goes to there and come out here, go behind there and come to this one. And from here it come out, it goes to actually this one to jumper to all of them. Now, normally use a copper plate here. Okay. Okay. So and then this is all the house green wire goes to this bar. That's called the earth bar. And all the house neutral wire go to this one. And this neutral from this one is joined to this point here. Yeah, so this bar is the incoming neutral, and all the house black wire all goes to this bar. This is the neutral bar. This is the earth bar. Okay. Okay. So you must know this dB. Okay. So okay. MSB is the bigger one. Okay. MSB is like UTS, factory, bigger things use MSB. Okay. And then substation. Okay. One whole state uses substation. Okay. So the famous substations in Sarawak are Oya Road. You know what's Oya Road, right? Right out of UTS is the 132 kV. You see the line. You see when you're electrical, you should be looking at all these kind of things. See, before I was not looking at all this thing over our head. After I moved to electrical, I always look at them. Okay, you should be looking at it. That one is 132. You see the shape. That shape always 132. Okay. Okay. So that one is right in front of UTS, right? And then you go this way down is Oya Road. Okay. And Oya Road is the sub of Cebu. Basically, the electric from Bakun is coming to Oya Road. From Oya Road, it goes to the rest of Cebu. Okay, so that's a sub. Another famous sub, the biggest in Sarawak, is Samalaju. And Samalaju sub. Okay, Samalaju sub. Okay, so Samalaju is the biggest because the load in Samalaju is the biggest in Sarawak. Okay, the second biggest load in Sarawak is Kuching City. Okay, Kuching City is quite big city because even Malaysia wide area wise, I think is probably the largest. Okay. Even population wise, it's about a million. I calculated that it's about a million. Okay. So it's considered, even Malaysia wide, it's quite a big city. Okay. So the sub for Kuching is Mambong. Okay. And sub for Miri is Tudang. Okay. So these are the subs. Okay. So uh, this one give protection to your home. Okay. This one give protection to your home. Okay. The MSP give protection to a building like UTS and factories. Okay. Substation give protection to the state grid. Okay. So once you go from this one, you go to MSP is higher technology. From MSP to substation is even more high technology. Once you go to substation, the very latest technology, you got fiber optics, you got all the latest computer systems. Okay. But one thing you realize, like, you take a computer system, like laptop. No. One thing different about substation equipment, cannot make mistake. Your laptop can make mistake, right? Substation cannot make mistake. The electrical system is very low tolerance for mistake. Okay. That is why electronic engineer, they don't want to give them IR in power. Okay. Because electronic, you have this thing. You make a mistake, yeah, okay, bond now, whatever. It's on 800 ringgit. What to do? Make a mistake. Gone. Power, you don't make small mistake. The mistake is like 10 million. Transformer blow in Bintulu, $10 million. It really happened. My friend is a scrapyard guy. Said, Prashok, you must go to Bintulu. These people, they don't know what to do. I made a lot of money. I collect a scrap transformer from them. 10 million. Okay. They don't know how to connect properly also. Better go there, he told me. Okay. I don't know. It's not so easy for me to go there also, because to get jobs like that, all need politics also. I'm not very strong in politics. Okay, I don't know any politicians. Maybe I do one or two, but very few. Okay. I found out that business all take politics. Okay. That's why I'm back to university. Okay. I tried to do business, but because it took too much politics and I don't have politics, I back in university. Okay. Okay, so you must know this difference lah. So the DB is the home one. The MSB is for like UTS, big building, all the big building in Cebu town is using MSB. Okay. Substation is like for state grid, like the Oya Road sub. Okay. So petrol station have MSB. That's what I did last week. I went to petrol station Miri and then inspecting the MSB. You see, how it works is you got two relays. These are the two brains to detect problems in your system. The two brains. Okay. And these brains are supposed to trip your main breaker. Okay. So these brains are supposed to trip this one, because it's an incoming. Something wrong. Okay, trip. They detect different problems. This detect earth fault. This detect overcurrent. Okay. If one of these is detected, okay, trip. And then let the technician figure out what's going on. Okay. So that's how the system works. But the signal from this one is a shunt trip wire. Okay. And it goes to a fuse before it goes here. Because of fuse. What if the fuse is gone and there's some big problem in the Petronas? Okay, any building like UTS. This one detects something wrong. You want to go, but the fuse is blown. This is not the power. The power is different wire. See that the power is here. Okay, so this is the power. I just make it simple. Okay, this is the power. Okay, so this is a power wire. But there's some problem. This one detects something wrong. So it sends a signal through this wire, and it's supposed to strip this one because the power wire is still going into the building like UTS. But this one detects something wrong. But you want to go, the fuse is blown. How can you go there? How can it trip? The fuse is blown. Okay, so that is why you never put fuse on a critical wire. Okay, you don't ever put a fuse on a critical wire like this. The fuse blown, how can it go? How can it protect? Okay, so you never put a fuse on a critical wire. Okay, there's another equipment, surge arrestor. Surge arrestor. Okay, so there's another equipment, surge arrestor. This is for lightning protection. Okay, so it normally how it's connected is like this. Okay, so this like this DB don't have it. Yeah, so this is incoming. It goes to surge arrestor and then this one go to earth, and then it loop to here. So basically, in this one, you have to put it on the very end here. But this one I think too small. It cannot fit unless you take out some of this one. Then you can put one surge arrestor here, and then the RCD. From RCD it goes to this one. Okay. So what is inside the surge arrestor is zinc oxide. Okay. Zinc oxide is inside there. When lightning come, the zinc is one material that doesn't like to stick to anything. Okay. You know what is galvanized iron? I think this is galvanized. Yeah, this one should be galvanized. I think so. Yeah, this iron, but the outside they put zinc. Why? Because iron like to rust, right? So when you put zinc on top, it doesn't rust. That's called galvanized iron. You see all the street poles, the street lamp, they're all shining. That's galvanized. Okay. So I see they make it actually in Kuching. There's a factory making it. Okay. When they weld all the street lamp or street poles, the electric poles, it look very ugly because welding here, welding there look very ugly, right? So they take the whole thing, they put it into a bath of zinc, molten zinc, come out, wow, very beautiful. Okay. So that is called galvanizing. Okay. So the reason they do that is so that the iron doesn't rust anymore. So because zinc is one element that doesn't like to join to anything else. It doesn't like to join to oxygen, doesn't like to join to anything. It likes to stay alone. Okay. So what you do is you force the zinc due to using high pressure and temperature, you force the zinc to join to oxygen. Okay. And then when lightning comes, the zinc and oxygen split, and zinc is a metal. Metals are conductors. So you just leak down here. Okay. So okay, so zinc is a conductor, and all metals are conductors. Okay. 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 So but there are some people who actually put a fuse here. Okay. I won't. I didn't do it in my home. Some people put a fuse here. In fact, in UTS, it's 100% they put a fuse here. There are some who say it's okay because lightning happens very fast. This one leaks, and it leaks in a fraction of a second, and after that, this one blow, and then the current doesn't come in anymore. So in that sense, it makes sense now. Okay, but I don't like the fuse there. In my house, I didn't put one of this one. Okay, but this one definitely wrong. This one definitely wrong. You see, this is a power. These are the brains. The brain detects something wrong, and the wire carrying the signal that something is wrong to this one, they put a fuse there. That fuse blow, this one still go on. The fault still carrying on in your UTS. Some big fault is happening. This one detect the fault, but it detect the fault, it cannot go through. So the fault still happening in UTS. That's very dangerous. It can be a big short circuit. Short circuit is very dangerous. You see, what is short circuit? You see, live and neutral. When you touch live and neutral, V equal IR. Okay, you look at this. V equal IR, I equal V over R. So 240 over 0.02. Why 0.02? Roughly estimate the ohms of the copper. Okay, it should be very, very low. So the I suddenly becomes 12,000. So short circuit is a different story altogether. Okay, it's not the normal thing. I've experienced once. Okay, it, I mean, you know that your house, even one of you is a richer person than others. I think maximum is about 50 amps. A typical house can be using at one time. Normal house, my house is only about 10 to 20 amps mostly. Okay, because we tend not to use aircon in my house. Yeah, now my wife does, but my children don't. But in the front hall, normally no aircon. So normally between 10 and 20 amps only in my house. Okay. Uh, yeah, I had to connect aircon in every room because one of my son has a he I don't know he really needed aircon. And I connect for one son and the other two don't have aircon now. As a father you cannot do like that. If one son get, other two must have also. So I had to connect in all three three room. I had to connect aircon. Okay, I mean my father was not rich. My father was quite poor, and he has five sons. And he buys something for one son, he had to buy for all the sons. It's like that. As a parent, you need to do like that. But this one has a medical problem, so I really needed aircon. Well, you cannot buy for one child. You must buy for all three. It's like that. Parent must be like that. You cannot discriminate against one child. Okay. So that's why all my children's room has aircon. But they seldom use. I seldom see them use. But my wife does use. But despite all that, uh, my house amps only about 10 to 20 amps only. Okay. Look at this number. This is 12,000 amps. Okay. Okay. Uh, that's a huge amount of amps. Okay. So I experienced it once because I was, once a year per Rayaan, they asked me to do about 20 frozen tube. Normally per Rayaan they use frozen tube very bright now. Right. So 20 frozen tube, and every year they ask me to do something. So I recycle, the cheapest wire, the red and black wire. So I buy every year. I buy and I connect, and then that recycle wire is short already. Okay, because too many years I use it and I kept it for store for 1 year and then take it out again. It's actually short. I finished my job and then I stepping on the wire with my slipper and I on the power. Immediately I can feel the heat going through my slipper to my leg. That is totally end. Okay. So short circuit is something different story. Right, it goes through your slipper immediately. Okay. So that gives me an idea also, kettle, like this kind of thing, water heater. They use a resistor wire inside there. So if you actually give a small short circuit inside there, it is super fast. I don't know if this one, because this particular one, I'm quite happy with it, lah. Philips brand, but it is quite fast, lah. This one really is. I on it already straight away got sound. Maybe they're using that method. I'm not very sure. Okay. But I can tell you that I've seen a lot of people. I think a lot of people's home have this one, and you as student also, some of you have this one. If you haven't bought, don't buy ala alang. I tell you, a lot of people buy plastic one. I tell you that's super dangerous. How can you boil water in plastic? That's not safety. Plastic is very dangerous. Anything plastic, the plastic molecules will go out into the water, and you're drinking the plastic. It's very bad for you. Okay. Okay. Uh, if you buy this one, you buy metal. See my bottle also metal safety. Okay. Okay. All my children, I bought this one all through their school. So this guy, I don't know, he don't know what he does with it. This is my children one lah. Okay. And then he made a hole. I put silicone in it. Okay, I use it. Okay. Okay. I still recycle. Okay. But if you want to buy, I'm sure as a student, a lot of you buy this one. You get a metal one lah. A bit more expensive. I think the plastic one 30 ringgit. This one maybe 100 ringgit. Worth it lah. It is your life you're talking about. Drinking plastic, boiled plastic is very dangerous for you. What for? You go to hospital later and spend much more money at that. Okay. So each time you have a bad habit, you think about it, your hospital bill will increase that much more. Okay. So is it worth it or not? Okay. So so this is something I hope you don't do this when you go out lah. Put a fuse here. I don't know why mistake in logic of the people, or they don't understand at all how this system works. Okay, and I need you to memorize. Okay, this won't come on next week, but next week is just the as principle. But I need you to memorize this schematic of this one. Yes, the schematic is uh, okay. These are the the bars, the red, yellow, blue bars. Okay, on the bars there are cities. Okay, these things are called protection cities. What is city? It's a current transformer. City is a current transformer. Okay. So out of this one, there are two terminals. Each of this has got two terminals. Okay. Out of this one, got two terminals. Okay. And it goes to Okay, so that's how you work. Okay, so these are the four: red, yellow, blue, and neutral. Okay, I'll send this to you, but you need to produce this for me for final exam. Okay, okay. So you got red, yellow, blue, neutral, uh, and there are two terminals on this. These terminals got name also. Okay, the terminals are S1, S2. You cannot make the wrong. You cannot connect wrongly. S1 means all S1. Okay, S2 means if S1 is on top, all must be S1 on top. Okay, if you connect wrongly, that means here S1, here S2, you cause a fire. Okay, very dangerous. Okay, so all the S1 goes to OC, and from neutral city, go to the middle of this one and join this one all combine and join to this one. Okay, and that one go to a fault and come back. This one all green wire. Okay, so this one all green wire. Join to the S2. Okay, so you need to produce this for me for example, because this is the main protection circuit for all MSP. Okay, okay. So this is the MSP protection circuit. Okay, okay, and from this and this, go is a shunt trip wire. This and this is shunt trip wire that goes to the MCCB. Okay, so the MCCB has the power wires, red, yellow, blue. Okay, so that's a complete circuit now. Okay, so all electrical engineers, you're going to go to field to work, you must know the circuit. Judgment exam, guarantee this one come out. We must draw this one for our judgment exam. Okay, so that's why I'm saying, why would they put a fuse here? I mean, I already tell you this one. Do you think it's logical to put a fuse here? There can be no logic to put a fuse here. It's the brain that tells something is wrong. And he already tells something is wrong, but he cannot go through because of the fuse here. He cannot send signal to this one to trip. The whole idea is to trip. The whole idea of this system is to get this one to trip. But now you put a fuse here, this one cannot trip. Okay? So this definitely come on your exam, your protection scheme. Okay? Okay? So that is the main protection for buildings. You know, sometimes people say, this one no need to teach safety. This is the main safety. The safety of the whole building, big giant building like UTS, depend on this system. Okay? Of course, there are many of these systems replicate the system, but this is the system that protects the building. Okay, and it's because of people not understanding this, they can put a fuse there. Okay, they can put a fuse on this wire. Okay, you don't put on critical wires like this. You don't put a fuse. You see, I was repairing one building. Yeah, I show you. Okay. You see, you look at this. They put this fuse. This is the shunt trip wire. And the worst case about this one, let me. This is a shunt trip wire going to MCCB. They screw on the fuse on the plastic. Oh. This factory will never trip. No matter how strong your brain is, the OCNL fault is the brain, right? OCNL fault supposed to give signal, but they put a fuse here and then they screw the wire on the plastic here. This factory will never trip. Okay? Okay? So I can send you this one. Okay. Okay, so uh, uh, okay, sorry, I just send you the email. You can take a look at it, and then I'll send you these notes as well now. Okay, I think now we start at about 45. We can stop the class now. Okay, so I'll send you the notes. You go through the notes, and remember next week is progress test 1, so it must be in class. Okay, and the topic will be the iceberg principle. And just remember, the whole reason of teaching you iceberg principle is to tell you how expensive. Okay, and then if you are engineer that you cannot, your boss there cannot afford the solution, you show him the calculation, then he will afford the calculation because the number is far more than what you're going to buy. Okay, okay, and then now it's more strict now because I talk to safety officers. Some of my friends were safety officers because we all returned from the factory, so a lot of them went to become safety officers. So when long ago I talked to them because we are out of the factory for 12 years already. Okay, 13 years. So when I first talked to them, they said, yeah, my boss don't listen to me. I tell him this safety, that safety. I'm okay, you listen to me. I don't listen to you. But now I talk to the same people. They said, no, now boss all listen to us already. So they are very scared already. All the big contractors, okay, are very scared of the safety officer. Okay, safety officer got a lot of link direct to the DOSH. Okay, they make a small report that okay, I'll be in trouble. But which is actually good, you know. It's not that the Tauke is hiring a betrayer to his company. The safety officer is doing good to the factory. Okay, he's reporting about a safety issue is good for the Tauke's money, not anything else. Okay, the Tauke can make tons of money if you follow safety. Okay, so it is a trend you should know that in the old days the Tauke tend not to listen to their own safety officer. They need to take a safety officer because it was a law, but they tend not to listen to them. But now, the same people told me, I met them recently, or they're all listening to us now. The Tauke are all listening to them. Although don't make crazy suggestions. Now, of course, you're a safety officer, you have a knowledge of safety, so you give correct suggestions. Okay. Okay, that's the end of class.